This particular lesson talks about sum to infinity for a geometric sequence, and this is a exclusively HL topic. The notation for sum to infinity is given as S infinity, S denoting the sum and infinity denoting the number of terms. And the idea of sum of a geometric sequence, let's start with the formula, is a times r raised to n minus 1 upon r minus 1, correct? If the ratio was less than 1, okay, that means between minus 1 and plus 1, not equal to but between them. What happens to a fraction when it's multiplied with itself? So if it's between minus 1 and plus 1, then it means r is like a fraction, so like half. So let's see what happens when fraction gets multiplied with itself. Why am I looking at multiplying with itself? Because I have this term r raised to n in the formula, right? That means ratio is multiplied with itself n times. So half times half is 1/4. 1/4 times half is 1/8. 1/8 times half is 1/16. 1/16 times half is 1/32. So the terms are going on becoming smaller and smaller. Let me graph it for you as well, for you to appreciate this idea of half raised to x. I know it is not a real number, it has to be number of terms, correct, but just showing you the values. Or if you want, you can look at a table of values. That will be better. Then you can think of 1, 2, 3, 4, and you can do half, you can do 1/4 and 1/8, 1/16. These are the values actually, it's not really. So these are the values. So do you see that the values are becoming smaller and smaller? They're approaching 0. You're right that they'll never reach 0, but they're almost. In practical situation, that half raised to say maybe 100 or something will almost become negligible. So in my formula, a times r raised to n minus 1 upon r minus 1, this r raised to n, when r is between minus 1 and plus 1, and when n is tending to infinity, that means very large number of terms are being done, then r raised to n is really tending to 0. It's a negligible value. So a times my r raised to n is almost 0. So 0 minus 1 upon r minus 1. So the sum to infinity can be approximated by a upon 1 minus r, because r raised to n will be negligible amount, and that is called sum to infinity. And this only happens when the value of r is less than 1. Otherwise it is not. Let me give an example. I want to express this number, this recurring number 2, 3, 2, 3, 2, 3, and goes on into a rational number. Remember, you used to do this when you were in middle school. When you were introduced to irrational numbers, this was one exercise that was being done. So that means I have to express in the form of p by q, where q is not 0 and p and q are integers. They belong to positive integers. So that's what I want to do. So let me see, but where is geometric sequence in this? Well, you will know that. So I'm rewriting this number 0.232323 recurring as 0.23 plus 0.0023 plus 0.00000023, oh sorry, 4 zeros only, 23 plus 6 zeros and 23 and so on. Till where will it go? Infinitely, because recurring number means it keeps going on. So I have to ideally write this as dot 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 because it goes on. And now I am rewriting this number as 23 divided by 100 plus 23 divided by 100 times 1 by 100 plus 23 divided by 100 times 1 by 100 square, and so on. Does this look like a geometric sequence? Yes, where A is my 23 by 100 and my common ratio is 1 by 100. So it's look like A into R, A into R square, and so on. So R is definitely between minus 1 and plus 1. So if I continue, because this is like sum to infinity terms, S infinity should be the first term, times 1 upon 1 minus R. 1 upon. So 23 by 100 times 100 by 99, which is 23 by 99. Do you remember we used to do it by a slightly different method in middle school? But yes, it was always all nines in the denominator whenever we used to convert a recurring number into a rational number. And that's what we could do by using my concept of a sum to infinity. Fractals are a very common example when we are looking at sum to infinity. We will be looking at some examples in worksheets, but otherwise you are free to explore fractals as one of your it could also become a topic for your exploration, because that's an application of terms to infinity, sum of terms to infinity in case of a geometric sequence. In fact, fractals combine some knowledge of arithmetic sequence and geometric sequence.